My name is Gurkiyat, and I'll be introducing you to RDC, Reliability Demonstration Chart, how we created them, and how we analyzed them. First, we had about 31 defect reports that were given as a part of the assignment, and then we combined those defects and the time interval relative to them to create only 16 defects. Those 16 defects we then normalized to with respect to 16 because we can't go, our failure, the total number of failures that were given in the data were 92 and we can only represent 16 on the given Excel sheet. So we had to normalize it with respect to 16. Some say that you can do it with a subset of the data, but we wanted to use all of the data to see how the software actually performs. Then assignment asked to get some minimum value of mean time to failure in which the software just become acceptable. And we calculated all of the number of bugs that were given in the data and all of the time that the computer used to identify all those failures, then calculated the MTF, we get approximately equal to 1. And while we were plotting, when we entered this data into our plot, see here, we only entered the MTTF equal to 1. We get the data that just satisfy the condition that was actually asked in the assignment. So after doing it, we kind of like did the representation of all the points. We entered all the failure data into this column and when they were observed. And so after doing all of this, it was asked to analyze the data at half of the MTTF and twice the MTTF. So now if we input the data as half of the MTTF and see, and the software just the software actually is rejected. So now the software, the actual number of failure that we are getting is way too high. It's and the second condition was to do the data in twice the MTTF, the minimum MTF. Now, if we do it in twice, the software actually becomes much more reliable and thus is in the acceptable region. This happened because as we increase or decrease the MTTF, if we increase the MTTF, the number of errors that could occur in that time are halved actually. So all of the points are scaled on the right side, and if we decrease our MTTF, we are actually getting twice as many errors in that same time interval, and all of our graph is actually moved toward the left side.
Hello, this is Jaskaran, and in this part of the assignment, we are doing the reliability growth testing, reliability growth analysis of the failure dataset that was provided to us in the artifacts. And this is the actual data that we will be using for our assignment. The columns here represent the time interval, failure count, execution time measured in hours, failure identification work measured in person hours. So that's the number of hours that it takes for a person to recognize the failure. And see here is the computer time failure identification. That's the number of hours taken by a computer to detect a failure. So we have used the dataset as it is in the tool CSFRAT. This was the second tool that was suggested in the assignment, and we loaded data directly like this. And as you can see, we are using, there are total 31 points of the data set, and we are going to be using 27 of them. And the goal here is to capture the growth trend of the failures so that we can estimate the time when the specific growth goal would be achieved. So as all these models are aimed to capture this trend, and we have 8 of them available with us, and all of these models, they can be trained with the fixed number of covariates. So EFC, they represent the same fields available here. Okay, so we will select all the models and we will also select all the options available with each model, and then we will um, train each and every combination of possible combination of the models. So there, as you can see, 8 into 8, this is there are total 64 models. So right now we are training each of the model. It takes a little while, and then from 64 models we will be choosing the best performing models. Okay, it seems it's done now. So on model results and predictions tab, let's visualize some of them. As you can see, this is the fit of the trained models, and this is the actual data. The best models will have their lines or their predictions closer to the actual models data. But as you can see here, uh, all of these models, they don't seem to be working well. They don't seem to be capturing the growth trend of the data set. So we will be choosing the best models out of all of the available models. So if you move on to the models below, all of the models seems to be fitting well to the data set. So that's so that's where we chose the best models, and this is mentioned in the report. In the model comparison tab, all of the metrics are available with us, and these metrics can also be used to check the or to select the best model. And from this tab, we can see what would be the growth reliability growth trend. Thank you.
Hi, my name is Ramneek. I'm going to present some points on RDC. RDC analysis is a very time and cost efficient way of analyzing the reliability of the system. It can demonstrate the reliability of the system to support decisions. One of the disadvantages of the RDC analysis is that it cannot come up with a quantitative measure for the reliability or availability of the system under the test. It can only demonstrate the trend of changes and how they affect the reliability of the system. Another disadvantage is that experimenting with different values of confidence levels and MTTVF, what if scenarios is possible but rather difficult to do. One more important point is that it is an open source project.
Hi, this is Sukraj. So I'm going to explain you the reliability growth testing that we are doing in this lab. And we were given the data that we have in an Excel sheet, and we used the data from the column number E, and we converted that data into this notepad format, and to remove the data which was having a zero value. And then we imported that data into the tool, and we imported that data into this reliability tool, and then we run the Littlewood and Bayesian reliability model on it, and then we tested or applied the trend analysis on it. And as you can see, these were the predictions that we received from this tool based on the data that we imported into it. And here you can see the prediction versus raw and versus scratch V, and this is the growth prediction testing for the data that we imported in. Thank you.